Now let's see how we can use square roots to solve equations. Let's, for example, solve this equation. We have x squared equals 4. So because we have x squared, if we want to isolate or get x by itself, that is our goal when the directions say to solve, we would want to do the inverse or opposite operation of squaring, which would be to take the square root. But if I take the square root of both sides, we have to indicate that both roots are possible with the plus or minus symbol. Because again, with a variable, we don't have enough information to know if it's the positive or negative square root. So we want to take the square root of 4. We want to indicate that it could be the plus or minus root. So our answer will be plus or minus 2. We're keeping both roots. If square root of 4 had been my interim answer, the result would have only been the positive 2. So let's look at 3 examples to see how to use the context to determine the signs of answering of the answers resulting from square roots, if it should be just the positive 2, if it should be just the negative 2, or should it be both. So our first example is we have a number n of coins is given by the equation n squared equals 16, and we're told to solve for n. So if we have our equation n squared equals 16 and we go to take the square root of both sides to solve for n, think, are we going to have the positive square root only, the negative square root of 16 only, or do we want both the positive and the negative square root of 16 for our answer? Well, when we take the square root of 16, let's say or the square root of both sides, because we're undoing that squaring, and that does leave us with just the number of coins n. But if we indicate plus or minus the square root of 16, that would be plus or minus 4. But only the positive solution of plus 4 is valid since the number of coins can't be negative. So in this case, we discard that negative 4 square root. We discard that negative solution. And our answer is that there are 4 coins. N equals positive 4. Let's take a look at this example. Here we have the height h of a submarine above sea level is given by h squared equals 169. So we want to solve for h. So again, if h squared equals 169, we're going to take the square root of both sides to undo squaring that h because we want to get h by itself. But think, is it going to be just the positive root of 169? Is it the negative square root of 169, or is it both? Well, here we take the square root of 169 and the square root of h squared, so that undoes the squaring and leaves us with h. Now, if we're thinking about 13 and negative 13, think of a submarine. Only the negative solution of negative 13 is relevant since the height of a submarine above sea level will always be 0 or negative. You're going below sea level, so that's negative from being above sea level. So it's going to be that negative answer only of h equals negative 13. So in this case, we actually discarded the positive solution. And finally, let's look at the third example. Here we have a ball shot up from the ground is at its highest point at t equals 0. During its flight, the times it is at ground level are given by t squared equals 81. Solve for t. So when we take the square root of both sides to isolate t to undo that squaring of t, again, think about it. When you have the ball shooting up from the ground, we're looking for the times it is on the ground. So think, would that be the positive square root of 81, the negative square root of 81, or both? So here, when we actually take the square root of both sides, it undoes squaring t and leaves us with just t. And here we would have the plus or minus square root of 81, which is going to give us an answer of plus or minus 9. So in this case, both solutions of positive 9 and negative 9 are relevant since the ball began on the ground 9 seconds before reaching its highest point at t equals negative 9 seconds, and then it ends up on the ground 9 seconds after reaching its highest point at t equals 9 seconds. You can think almost if the ball's on the ground here, it's going up, up, up to reach its highest point and then going back down on the ground. If this is the highest point, you have over here being t equals -9, and you have over here where the time equals the +9. So in this case, we keep both solutions. So you really have to read the context of the problem in order to know which root you're going to keep, the positive, negative, or both.